So on test two, the first page, it's going to be a series of questions about is this a function, domain, and range. All right, just so that we're all straight. Test two, intermediate algebra, functions. So one area of problems that you're going to see is kind of here's a graph, and is this graph a function? So as you look at if a graph is a function or not, the one of the things that you need to ask yourself is, does it pass the vertical line test? Meaning, if you draw vertical lines through the graph, will every vertical line hit the graph in one spot? And the answer is yes. Now, some people will say, well, if you draw it over here, it won't hit at all. Okay, that's a fair point, but it don't hit twice. So whether it hits it or not doesn't matter. It's whether it hits it twice. And so what would have to happen in order for it to hit twice? In order for a graph to hit twice, what would have to occur is that the picture would have to be something like kind of along the order of, it would have to have some kind of circle involved. It would have to be kind of a sideways U. It would have to be a U turned this way. It would have to, or be some kind of oval. All of these would have a line that hits twice. Does that make sense? So those would all not be functions, and even though they're not functions, they would still have domain and range. Does that make sense? So anytime you have it where it hits one time, then that makes it a function. So for the question, is this a function? The answer is It's just bam. Yes, it is. All right. It is a function because it passes the vertical line test. All right. Now, what is the domain? The domain then becomes if we get on the graph and we start to trace it. So if we get on the graph and we start to trace it, how far left will it go? How far left does the graph go? Well, remember that as we read it left, we either come to a point or we come to an arrow. Does everybody remember that? And on the left-hand side, we have negative infinity, and on the right-hand side, we have positive infinity. Does that make sense? So if we come to an arrow on the left-hand side, we would use negative infinity. So it starts at negative infinity. Okay. Now, how far does it go to the right? It goes to 6. So the domain would be negative infinity to 6. And then you'd put a bracket on the 6 because that point is included. Okay? Pretty much for you, if it's a point, it's always included. Okay, at least at this point in your life. Next semester, we'll figure out why it's not included at other times, but right now, it is always included. Okay? Now, what's the range? So as I read this graph to the bottom, remember that we start from the bottom on the range. As I read to the bottom, do I run into an arrow or do I run into a point? I run into a point. Okay? That point is where? At 0. A lot of people will say 6. Now you're crossing platforms. Because 6 is the x value. I'm talking about the y values. So the range starts at 0 and goes to what? So for the range, remember that infinity is at the top and negative infinity is at the bottom. Those are terrible infinities, but you get the idea. All right? If we run into an arrow at the top, that's infinity. So it's 0 to infinity. Any questions on that? We good? All right. Now, solve by substitution. What does that mean? What does that mean? Dakota, what's it mean?
So you just try to find, eliminate one of the values by making one equal to.
Not quite. What are we going to do, AJ?
Take the first equation and plug it in for y.
Okay. So we're going to take the first equation and plug it in for y. And I don't know where my highlighter is. Where the freaking hell is my highlighter? Oh, here it is. We're going to take the first equation and we're going to plug it in right here. So what this is going to look like is, what's a magic pen? So what it's going to look like is 2x minus 3. I swear to God, this is horrendous. Thank you, tech support. X minus 8. You know what? Screw that shit. Watch this. It would be 2x minus 3 times 3x minus 8 equals 8. Do we all agree? What's wrong?
On the board it says 3x.
You know me? Do not ever correct me again. That's so not cool. I don't even know how to fix this stupid thing. Oh, look at me. Call Winter Haven for that one. All right, we straight?
Yeah, right.
Okay. So now, from here, we're going to, sure would love to use the pen. From here, we're going to distribute. That's talent, folks. And when we distribute, we get, what are we going to get? 2x minus 9x plus 15, yes? Equals 8. Do we agree? Then from there, we'll get negative 7x plus 15 equals 8. We agree? From there, we'll get, we'll subtract 15 to both sides. Yes? All right. And we'll get negative 7x equals, was that negative 7? Right? And then from there, we'll get x equals 1. We agree? Now, once we get x equals 1, then we got to turn around and take this and go plug it back in. Now, remember, you can either plug it in here or you can plug it in here. Either one, it doesn't matter. It makes no difference functionally which one you plug it into. You should get the same answer both times. I will plug it into the top one only because when doing so, it's already got y by itself. Does that make sense? If I plug it into the bottom one, I got to solve for y after I get done. So substituting it back in. I get y equals 3 times negative 1, or excuse me, 3 times 1 minus 5, which gives me y equals negative 2. Do we agree? And then to finish this up, you would put it in ordered pair, which you would say it would be 1, comma, negative 2. Does that make sense? Okay. Now, probably one of the most commonly missed test questions that I give is this question right here. And I think the reason why it's commonly missed, no offense, is we don't ever go over it. So maybe that might be the reason why it's commonly missed. Now, the reason why I generally don't go over it is I'm asking you to solve by graphing. So really all I'm asking you to do is graph 2 lines. But I think what happens to people, because we don't go over it in class so much, they think it means solve it and then take a dot and stick it where the answer is. That's not what I'm asking you to do. I'm asking you to graph this equation and this equation. Now, how do I graph x plus y equals 4? Well, remember, to graph, you either what? Find the x and y intercepts or slope-intercept form, yes? So for that one, I'm going to go ahead and find the x and y intercepts. I actually do that for both. So to find the x-intercept, I'm going to plug in y is 0, right? So I'll get x plus 0 equals 4. And then to find the y-intercept, I'll plug in x is 0 and get 0 plus y equals 4, yes? So that gives me 2 points. 1 point will be x is 4, and 1 point will be y is 4. Do we agree? Now, from there, we get that line. Does that make sense? Now to do the other one, plugging in x is 0, you get 1. Plugging in y is 0, you get x is 1. And plugging in x is 0, you get negative 2. Do we agree? Does everybody see that? Now, graphing that. Now, this is solving by graphing. So now I've graphed those 2 points. So what do I do? Once I graph those 2 points, what am I looking for? I'm looking for this point of intersection. That's actually the answer. Does that make sense? So when I say solve by graphing, what I don't mean for you to do, because here's what a lot of people do. When I say solve this by graphing, a lot of people go like this. They'll say, well, x plus y equals 4, 2x minus y equals 2, and then they'll just add straight down, right? So they'll just add straight down, and they'll say, well, 3x equals 6, x equals 2, then they'll plug that in and get y equals 2. Does that make sense? So I'm not saying that that's not the answer, but you cannot just add straight down, solve it, and then go, oh, 2, 2. You have to have drawn the lines on the graph. Does that make sense? You have to have drawn the lines on the graph. Once you do that, all you do is point out that this point of intersection is and then that becomes kind of what you write in that blank. Does that make sense? Going once, going twice. All right, how do we do this by elimination? How do we do this by elimination? Let me bring this over to the middle. How do we do it by elimination? Okay, so keep in mind that we can multiply by 4 All right, and we can multiply by -3. Now, what does that do? When I distribute this times this, I'm going to get -12. When I do -3 times 4, I'll get -12. Does everybody see that? And now they'll cancel. If you didn't want to use 4 and -3, what could you use? If you didn't want to use 4 and -3, you could use 7 and 5, yes? And 7 and 5 would do the same thing. All right, so we'll just go ahead and do 7 and 5 only because I can. Now, again, make sure that when you do 7, that you do it to all 3 pieces. That when you do 5, you do it to all 3 pieces. Does that make sense? And so what you'll get is 21x minus 35y equals 21 times 7 is 147. You'll get 20x plus 35y equals -65. We agree? Adding straight down. These will cancel. And you get 41x equals, what does that equal to? 82. 147 minus 65 is 82. Dividing by 41, you get x equals 2. Now, once you get x equals 2, what do? Once you get x is 2, what do? Take this, go here, or take it and go there. All right? Either way. So we'll just plug it into the bottom one, and we shall get 4 times 2 plus 7y equals -13. 8 plus 7y equals -13. 7y equals, was that -21? We agree? And then y is equal to -3. All right. We'll subtract 8. Okay. Any questions on that? So now, you got solved by substitution, right? You got solved by graphing, and you got solved by elimination. You are going to have to do all 3. Okay, we're going to have to do all 3. And those are covered in the book. I think it's section 4.1, I believe, or 3.1 is where you'll see them. It used to be 4.1, but I think it's 3.1 in the new book. Okay? But you are going to have to be able to do all 3. Now, when you get to a problem like this, and this one may be the hardest one that we have, what happens here is, anybody get this one? Anybody feel like they got it? Nomi, you think you got it? You're live on television, girl. Go ahead and tell me what you got. Nomi got no solution. Why did you get no solution, Nomi? Because everything cancels. And Jonathan's like, he does that all the time. I swear Jonathan's an accident. I don't even mean to do it. It's rigged. Missed you, Joseph. Here's the problem. When you take this and you plug it in, to here. All kinds of bad stuff happens. Let's take a look. We got 6x minus 2 times 3x minus 7 equals 14. I think we all agree that substitution is probably the easiest way to do that. You agree, Brad? So then we get 6x minus 6x plus 14 equals 14. Then these two cancel out, and you get 14 equals 14. Now, in the event that the x's cancel like that, if you get 14 equals 14, what does that mean? That means it's an identity. Now, here's the problem. The way the answer is going to be written in the book, when you see the answer, it's going to look really weird because it's going to look like this. They're going to use this kind of brace, and then they're going to write x, y, such that y equals 3x minus 7. And this is the way the answer is going to look. Now, you may be thinking to yourself, I don't know how to make that bigger. I apologize. I can make the box bigger. You may be looking at that going, well, that ain't what we did yesterday. What we did yesterday wasn't this problem. See, what we did yesterday was more like this. Y equals 2x plus 4, negative 4x plus 2y equals 7. So that when you took this and you plugged it in here, what happened was you got negative 4x plus 2 times 2x plus 4 equals 7. And then what happened was negative 4x plus 8 was equal to 7. What happened yesterday was we got 8 was equal to 7. Now notice that this, yesterday we said was no solution, right? Now why is it different? Why is this one different than this one? And the reason why it's different is this one you end up with 14 equals 14. They're the same numbers. This one you end up with 8 equals 7. Those are different numbers. Does everybody see the difference in the two problems? So if you end up with the same number, 0 equals 0, 5 equals 5, 12 equals 12, that would be an identity. If you end up with different numbers, that's no solution. Any questions on that? Any questions on that? At this point, we'll stop.